Right, now tell me, what do you mean by the Java Lang object class? What is the object class? What's so important with the object class? What is the object class? Anyone? Tell me quickly. Yes, tell me. Anyone? What is the Java Lang object class? You can hear me, right? Can you hear me?
Yes, sir.
Yes, good. Then tell me. Java Lang object class? No idea? Yes, right now. Okay, now last week we have discussed about the inheritance, no? Right now, under that we said that inheritance means acquiring uh, the properties or the methods declared in a class by another class is what you call as, like by becoming a subclass of a superclass is what you call as inheritance, right? So then in Java, right now, we have dealt with classes and then so on, right? And even let me create a class called item here, a new Java class called item. Right now in the class item, let's say I have item ID, I have item ID, and I have item name, string, item name, integer quantity, and the float price. Let's say I have some attributes. Right now we know how to create the construct and everything we know, right? So the getters, setters, construct, everything we know. No? For the time being, let's leave this as it is. And then we can start with the right. Then if we create an object from the item class, right now here inside the main method of another class, if you create item class object, item, let's say item equals new item, right? So if you create an item object and then if you create the item object, you just print it. If you just print the item you created, right now this would print some memory reference. Right now it would print you like what? The project location com.mycompany.maven project 2. Now this is the package name com.mycompany.maven project 2 dot item. The class name is item at a hexadecimal value 3p733d. Likewise, then this is a reference to an object. So if you create an object, now the way it should work, likewise, everything has defined in Java in a superclass. So, like in Java, there's something called superclass. Right now, for every class you create has a superclass. Right, therefore, everything here you do automatically become a subclass. Every class you create is a subclass. It has become automatically. Now, this item class is a subclass of the Java Lang.object class. Now, that is the subclass. Then, if you talk about the object class, Now object class is available inside the Java lang package. Therefore, every class you create in Java directly or indirectly inherits from the object class. Then, right, therefore, remember, if it is now for an example, if this item class is not inheriting from any other class, now this is not a subclass of any other class. So, this is a directly inherited from the Java language object class because this is a direct child from the object class. Therefore, if this becomes a subclass of another class, then this is inherited from that particular class, then that class inherited from the object class. Therefore, remember every class you create is a subclass of the Java language object class. Therefore, that's why I said directly or indirectly every class become a subclass of the Java language object class. So now for an example, if you have another class called furniture or the what do you call it? Furniture class, okay. Furniture class, and by the time if you declare furniture class become a subclass of the extends the item class. Right now furniture class is a subclass of the item class, and item class is a subclass of the Java language object class. So furniture class is also a indirectly inherited from the object class, but the item class is directly inheriting from the object class. That's why I said every Java class you create is directly or indirectly inherits from the object class or derived from the object class. Therefore, and what is this object class? Then object class has some methods. Object class has some behaviors declared. Why? Because when you do some basics with the every class you do, right now how the each class should behave has to be declared. No, then that is done by the Java language object class. Right now the object class has some set of methods like a toString method, very important, right? toString method, and we have the hash code. We have the hash code method, and then we have the what do you call hash code equals hash words and equals hash code equals toString clone. Likewise, there are several methods available in the uh, Java language object class. Therefore, for an example, toString method is very important because the default implementation of the toString method is to define the string representation of a Java class object. Therefore, string representation of an object. Now, according to that representation, when you print the item class object, now it prints package name at package name dot class name at and hexadecimal hash code. Now that is what the default implementation of the toString method. Now apart from this toString hash code equals, right now you have the clone method, right, and then you have finalize, and you have notify all. You have notify method and notify all, and then with the threads you have notify wait, notify all, get class, yes, get class. Likewise, there are several methods, inbuilt methods available in the Java language object class. Therefore, every Java class you create inherits these methods. Inherits these methods. Right now, for an example, now I will show you. Right now, you know method overloading, method overriding, and as well. Right now, if I create a furniture class item here, if I create a furniture class item, Right, if I print the furniture class item, like in order to make this work easier, let me refactor the package name into code. Then it would be easier, no? Then you will see under code, right? Now, if you run this application, now this would print code.furniture at hexadecimal hash code. Now, this is the default implementation of the uh, Java Lang.Object object class. That is the default implementation of the Java Lang.Object object class. Let's create the item class object as well. Item I equals new item. Now let's print the I. Now, when you run the item class objects, right now, when you run the item class object, now you can see, now it will show you code.item at code.item at code.item at a hexadecimal hash code and code.furniture at another hash code. Right now, if you have two objects from the same class, let's say if you have I and I1, and let me print the I1 as well. Right. Now, two objects from the same class, then it will have two different hash codes. Now, this is the default implementation of the toString method in the Java Lang.Object class. Now, Java Lang.Object class is the superclass for every class in Java, and then it has some set of methods like toString equals hash code, get class, wait, notify all, finalize. Right. Likewise, we have methods. Like under those, we're going to talk about toString hash code equals. We'll be basically talking and we'll be every time we'll be using toString and equals hereafter. Now, you need to remember the string representation. When you print an object of a class, the way it should print is defined in the toString method. So now toString method is declared, originally declared in the object class. No? So here that's why we are inheriting the way it has been implemented. So what I'm going to do is I'm going to implement it on the item class. I'm going to implement the toString method on the item class. Implement in the sense I need to override that has been inherited from the superclass. So we need to override it. In order to override, we need to do either you can write the toString method if you know the signature. Right now, toString method has to return a string value. Method name is toString, right? Likewise, you can do it. Just a minute. All right. Then here the toString method is declared in the superclass. So what I'm going to do is I'm going to override the toString method. The way it should work, I'm going to write it on the item class. So I know the return type access modifier public and the return type is string and public string and then the method name is toString. Right, now it has to return, let's say, return, I'm going to say test item class, test item. I'm just going to write return test item object. Now, I have just declared the toString method in the item class. So when I do it, it will suggest me to add the override annotation as well. For you to clearly see this toString method has been overridden here. Right now, if you want, you can add the override annotation as well. Let's see. Then you know this has been, we are overriding the toString method behavior. Now, if you print the item class objects, Now, if you print the item class object like previously, let's say how it should work, and then the furniture class objects, how it should work. Right. Now, the toString method is declared in the item class. Right. Then, now item class objects also prints test item object. Furniture class also prints test item object. Now, why the furniture items also prints like that? Because furniture class also, uh, furniture class has is furniture class is a subclass of the item class. Item class is a subclass of the Java language object class. So we have the object class. We have the object class. Now then we have the item class and we have the furniture class. At the bottom level, we have the furniture class. So now previously the toString method was declared in here at the object class. Now I have overridden the toString class in the item class. Now, the way the item class objects behave changes according to the overridden toString method. Since furniture is a subclass of the item class, so furniture objects also act according to the item class implementation. All right. Now, if you have any other class also, if you have subclass of the furniture class, then those also will work according to the way I have overridden the toString method. Right now, let's say now this is not the way I want. If you are using NetBeans or anything, I don't want you to waste your time like this. You just need to right click and then select the insert code and then select the toString method and select the fields if you want to display and then click generate. Then automatically that would display the item ID and all the values. So currently we don't have any values at the item class, no? For the objects we have not assigned, so the default values get printed. So the default values would be printed. See, now the default values would be printed. Right. Now that is how you declare the item class. If you the way you want to it to work, you can define it here. Let's say you don't want to have the item values, you just need to say display the item ID. First, you need to display the item name. You want to display the item name and right. Thereafter, you need to have, let's say, some dash. Okay, and comma. So, my bad. Item name and then the comma quantity and the price. That's what I want to display, let's say. Right. Now, item name plus quantity plus price. Right. Now, the way I want to work like this, then I can change it. Right. Now, if you run the class now, it would work like this. Right. Now, if you have the constructor to initialize the values as well, now you can see it will print item name null, quantity 0, price 0.0 because we have not the we don't have values assigned for this. So what I'm going to do is I'm going to insert the constructor for the item class by all the values. Right. Now I have the constructor. So here, if you want to create the item class objects, now this won't work. We need to pass the values because why? And the constructor is declared with parameters, so we need to pass the arguments. Right now, item ID, item name, share, and the quantity 10, and the price 1900.99 F. Right. Now that is one item, and for the furniture class also. Now the problem with the furniture class is, now we'll see. Now the item class is declared with the constructor. So if you want to become a subclass of the item class, then furniture class has to implement the constructor. So now that's the error you are getting. You have to declare the constructor. Then you can insert code, insert the constructor. Right now, if you want to create the furniture objects also, you need to pass the values. Then you need to pass the values. So um, I'm gonna pass values. Let's say the first item I'm gonna say mm, here this one also table bed quantity 5 item ID 102. But likewise, we can have the elements so when you pass, the toString method will print the objects accordingly. Right now, therefore, if you are overriding the toString method, make sure not to write the class names because the now if you say in the toString method here, if you say the item class or something, let's say at the beginning you say item class or something. If you write now, even the furniture objects also would print. Now we have declared the toString method saying item class and then item name and the values would get displayed. So the furniture objects also will do the same now. Because when you declare the furniture, when you print a furniture object also, now it would display item class. So in order to avoid that, you make sure not to get the class names hard coded. If you hard code the class name, then make sure that will suit to the scope. Now in this case, this is the furniture class object. No furniture class object when I print, I don't want to display item class, so therefore I don't need to display like this. Right. Now you know the way the toString method is working. Even if you want to, let's say, if you want to change the behavior right now, you want to have when you print the furniture class objects also, you want to display the way it should print. You need to change. So what you have to do, you need to override again the toString method there. Then you can say furniture class, whatever you want. And if you want, you can have you can implement the toString method. So if you print now, according to the particular class toString method, the behavior would change. Right now, that is how the toString method is working. See, now that is how the toString method is working. Right. Okay, quickly try out this by implementing the toString method. Right. Now, the toString method, the way it works is like this, right? Now, let's see the default implementation of the equals method. Now, the toString method is used to print. When you print an object of the class, how it should work, how it should behave. Now, that has to be declared in the toString method, right? Now, remember that. Now, if you have, now you know the equals method we have. So, the equals method. Then, how the equal method is working. Right. Now, let's see. Now, I have item object. So, I'm going to create another item object. Item I1 and I2. Item I1 and I2. Same values I'm passing. Right. Now, same values I'm passing. And I don't want to. Okay. I'm going to print the I1 object first. So, secondly, I'm going to print the I2 object. Right. Now, for the time being, let's leave the furniture class aside. Now, object. Now, I'm going to check whether I1 object is equals to I2. I1 dot equals I2. Let's check. I1 dot equals I2. Right. Now, I'm going to check whether I1 dot equals I2. Right. I1 dot equals I2. Now let's check whether what is going to be the result. Now you can see the same values I have passed. And also I'm going to create another object called I3. I3 is equals to I1. Right now the same object, I'm just going to update the reference. And I'm going to print that as well. I3, I1 dot equals I3. So I1 dot equals I3. Right. Now let's run it and see what it gonna work. Right now here it prints I1 first. Secondly, it would print I2 object. Same values it has to print. Now see, same values it has to print. When I check the equals method, now the first one, though we have the same values, I1 object and I2 object has the same set of values, but now you can see I1 dot I1 dot equals I2 returns false. I1 dot I2 returns false. Why? The reason is now even though the equals method check for the same reference, but the two I1 and I2 reference variables are referring to two objects, so it would print the false because equals method compare the given object with the current object, so it would print the since the references are two different objects, therefore it would print false. Right. Then if you want to change the behavior, now let's say when you compare an item object, what I want to do is I want to check whether both items has the same item ID. If the item ID is the same, I want to return true. If the same item ID, I want to return true. But now the equals method. Now, the current, right now, what does it do? Right now, the currently equals method now checks for the same reference. Right now, whether the two objects has the same reference. Now, when it comes to equals method, right now, remember, equals method checks whether the two objects are referring to the same thing. Right now, therefore, here, if the two objects are not referring to the same, now it would return false. Therefore, when you check the object dot equals, what happens is whether it will compare the two objects and then whether it both are the null or not. If the both objects are null, it will return true. Therefore, if the objects are not null, then uh, it would check whether how it works. Right. Now, for an example, let me make a comment of this. Item I1 equals null and item I2 equals null. Right. Now, if I run this application, now I1 is null and I3 also null. Therefore, now you can see here when I try to assign I1 is null. So when I try to compare the object dot equals with this, now this is a null method. Therefore, here you get an exception thrown. Right. So now remember, when you use the equals method, right now, it just simply it compare whether one object is equals to the other object. One object is equals to the other object. Therefore, the equal method is working for any non-null references. That is only working for non-null references, and that will return true if and only if both objects are referring to the same object. If the default implementation of the equal methods will return true if and only if both objects are referring to the same. When the both objects are referring to the same, it would return true. Otherwise, it would return false. So that's why when you check item I1 and I2, both has the same values, though that returns false. But when you say item I3 equals I1, and when you compare I1 and I3 objects, because both I1 and I3 refer to the same object, so that returns true. So remember, the equals method cannot be used with the null reference objects. So it will return true if the both objects are referring to the same. Right now, this is the default implementation of the object equals method. So if you want to change it, we can do it in the item class. So how? We need to override the equals method as well. Now let's see override the equals method. Now equals method also will return Boolean value, right? So now equals method will return Boolean method, and then the name is equal. And here it takes an object. Object O, let's say. It takes an object. Right. Now what does it do? Now what I want to do now, we are writing the way we want. Right now, whenever I receive an object, I need to check whether the object is from the item class. So I'm going to check if this particular item, if object O instance of item class. If it is an item class object, first I'm going to check whether this is an instance of the item class. If this is an instance of the item class, I'm going to check. I'm going to create item class object called I, let's say equals, and then I need to cast it into item class. Whatever the object, or let's say obj. It's easy, rather referring. Right now I'm checking whether if item ID, let's say I'm going to check with the item ID now. The semantic I want, if item ID equals to I dot item ID, I need to return true. Right, I want to return true. Now this, if it is even if this is not an instance of the item class, now I need to return false. Therefore, by default, this would return false. If the both items are having the same ID, then it would return true. Now it doesn't matter about the other values. Now you are checking only about the item ID. If the item ID is the same in two objects, it would return true. Right now, that would return true. Right now, let's see. Okay, right now, here, even we have table 100 and 5,900. Now you can see different values, but the item ID is the same. Right now, if you check, the item I1 equals I2, right now you can see different values, but same item ID. Now this would return true. Why? Because we are checking whether the two objects are having the same item ID. Therefore, now it would say, even though it's two different set of values, it will say true. Why? Because I1 and I2 are having the same item ID 101. So, I have changed the default implementation of the object dot equals method to work the way I want. How? To check whether if both objects are having the same item ID, then to return true, otherwise return false. If the two objects are having the same item ID, it will return true, otherwise false. Now that's how it works. Right. We quickly try out this equals method. Right. Equals method also can be inherited, can be generated. Right now, how can you generate? You just need to right click on the class and say insert code. You can select override method. Then you can select the equals. Then you select the equals. Right now, you will be able to get the equals method. Here, you can write the semantics the way you want. Right now, that is how you write the equals method. Then you can check whether uh, according to the way you want. Okay, quickly try out this as well. Right. Now that's how you check the equals method and then the hash code. Right now, if you ask what is the hash code and why we need to use the hash code, now every object you create, now Java Virtual Machine generates a unique number, which is a hash code. Therefore, that returns a specific integer for specific objects. Right now, hash code is not written in the address or memory address. Therefore, it returns a specific distinguished integer value. Right now, normally object equals method and the hash code go in and like together, because now normally if you want to like for an example, let's say you have sort of value objects to be stored in a sorted map or something hash map, let's say. Then let's say you are creating a program to store the words, whatever the based on the baskets. Now, if it is three-letter words, you're going to put into a basket. Likewise, then let's say you have basket which has three letters, which has okay. If you have another basket which has four letters, right? Likewise, you have then you have, let's say, 1 to 100 baskets based on the number of characters available. So, if you have cat, now you first check, okay, cat, three words. Then three words has to be put it inside the, now if it is cat, then you need to put it inside the three-letter basket. If it is house, HOUSE, then it has to be put it into the five-letter basket. Likewise, you need to put farm. If you have FARM farm, then you need to put it into the four-letter basket. But then, if you want to find it out, right now, when it comes to sorting, storing, when it comes to storing these words, right, you can use the hash code. Let's say based on the number of characters you're gonna return a value, then you can put the using the hash code. You can, for each object, you can generate the hash code. You can override the hash code. Based on the length, you know, return the length. Then the hash code, based on the hash code, you can find out which basket to put. If it is the word cat, if you have, then you know if it is 3 letter, then you need to put it into this bucket. If it is 3 letter, 4 letter word, if it is a chair, we need to put it to the 5 letter. If it is item, then you know it has to be put into the 4 letter basket. Likewise, then using the hash code, you can find out where to store. But when it comes to retrieving this, now the basket 3 may contain thousands of objects which has the length 3 characters. Now among those, you need to find out now the word cat. So first using the hash code, you can find out from the thousands of baskets which basket to check. Because of the hash code, you can find out, okay, 3. Then you need to find out 3. And thereafter, you need to check the specific word cat. Therefore, using the equals method, you can compare whether using the equals method, you can find out the exact object. Right. Now, right, let's say I want to just to show you how the hash code also works. Right now, let's implement the hash code also in the item class. Right now, right now, if it is the hash code, okay, if you just check the hash code here. I1 dot hash code and I2 dot hash code. Right now, I'm just going to print the I1 dot hash code and I2 dot hash code. Right. Right now, and also, right, okay. Now you can see I1 dot hash code and I2 dot hash code I'm printing. Now, when I print in the I1 dot hash code and I2 dot hash code, you can see some specific integer values, unique integer values got printed. Now, that is the default implementation of the hash. Right now, I just need to I just need to change the way it works. So what I have to do, I need to override the hash code method as well. In the item class, let's override the hash code. Right click, insert code, hash code. Right now, what I'm going to do, integer hash. Right now, I'm going to say return. Let's say I'm going to return the item ID because it's a integer value. No? Return the item ID. Item ID multiplied by 5. Okay. Item ID, just the item ID. Oh, multiplied by 10 or something you can have. Okay, I'm going to say or else item name dot length. Okay, the same thing I have item name dot length. Now return item name dot length. Now I need to return when it comes the hash code, return the item name dot length. Right now, here you can see when you are calling the objects, first one has chair char5, and then this one, let's say bed, it has 3. Right now, when you print the hash code for the I1 object, now it would print uh, chair, which is 4, which is not running. I'm fine. Right now, this would print 4 and 3. Right. Now, this is how the hash code is working. Now, see, the first one is 5. Chair is 1, 2, 3, 4, 5 letters, yes. And the bed is 3 letters. Right now, this would display according. Now, hash code is used to figure out the exact object. Right. And Right. So we have discussed up to now about the object class. And under the object class, that is a superclass in Java that is extended by all other classes directly or indirectly. And it has defined some standard set of methods which apply to all non-primitives and which has generic permits generic code to handle all type of objects. And it has some common interfaces like toString equals, clone, hash code, notify likewise. Then we just discussed about the toString method and the equals method. Right, toString equals and the hash code I just showed you. Right. Now the equals method decide whether two objects are meaningfully equivalent, and the hash code returns the hash code, and the toString method is just defining the string representation of the object. Right. Now you can read the rest as well. Right now, if you use the get class method, right now using the get class, if you okay, let me show you the get class method also. Right now, if you use this I1 dot get class, and then if it is, let's say, from the furniture class, right now I2 dot get class. Right now, if you just check the I2 dot get class. Class cannot be connected into one fresh type variable. Okay. Right. Okay. Let's figure it out this later on. Right. Now, if you just print the item of I1.get class method will return the class name as the item class. Right now, you can see class code.item. Now that would return code.item. Right now, let's say now if you have item variable I2 and you create a furniture object, and then you're going to get the class. Right now, in item variable reference variable, you have created a subtype of object, which is the furniture class object. You are creating a furniture class object. Right, then you can see now the this would display. Now this is from the furniture class. Now the I2 is referring to object, which is the furniture. So it would display the get class as furniture. Right. Now that is how the get class method is working, and we have discussed about the class types and toString method. We have discussed, and we have discussed about the equals method. And if the either object is null, equals returns false. If the classes are different, equals returns false. Therefore, equal method will display true if and only if the two objects are the same. Two references refer to the same object, then it will return true. The default implementation of the equals method. Right. Now we discussed that, and then the hash code. Hash codes are typically used to increase the performance of large collections of data. Right now, hash codes will JVM will generate a hash code for every object you create. Right. Now this is another example. Right now, for these keys, Alex, Bob, Dirk, and Fred, here you can see based on the alphabetical number letter, it generates a hash code. Now, when you want to store these Alex, Bob, Dirk, Fred, you based on the hash code, you find the respective basket and then you put. Then you can see Alex and Dirk has the same hash code 42. Then that has to put into the bucket, which is 42. Now, when it comes to retrieving this, now you need to look for the bucket 42. And then using the equals method, you have to look for the word Alex. Therefore, in real life hashing, you need to find the right bucket using the hash code method. and you can search the bucket for the right element using the equals method. Now, this is what we have discussed so far, and implementing hash code. So, I have showed you. And hash code requirements. There are some specific hash code requirements. If the x equals y equals true, then if two objects are the same, the default implementation I'm talking, okay? If the two objects are the same, the hash code has to be the same. Why? Equals method will return true if and only if two objects are referring to the same. Two references are referring to the same object, then only it will return true. So the hash code should be the same. If the hash codes are the same, then not required to be the x dot t equals y return true. But if x equals y false, that means equals method returns false, then not required, then obviously two different hash codes, two different objects. If the hash code methods are not equals, it is required the two equals method should return false. If the hash code is different, that means two different objects, no? So if the hash codes are different, obvious the equals method should return false. Right now, that is how the hash code and the two-string equals method works. And then I'm not going to talk further about the object class. Then I'm going to move into the collections framework. Under Java collections framework, we have that is an unified architecture which has some interfaces and some implementations and some algorithms. Right. Then we talk about what are these the algorithms we have and what are the interfaces we have. We'll discuss right now. Under collections in Java, you can say in different individual objects, a group of individual objects are represented as a single unit, as a Java collection of objects, right? Then the collection framework was declared in, I think, Java 1.5 or before that. Then the collection interface has the list and the maps. Likewise, we have, right, the sets and like we have queues, yes, list, queue, maps, and sets, right. Then when it comes to the collections framework, right now it has interfaces, it has different implementations, and it has set of algorithm. Right now, mainly the collections framework, you can say the collection interface or the util.collection and the map interface are the two main root interfaces of Java collection classes. And in Java collection framework, you have list interface, queue interface, and set interface, and the map interface. Then, therefore, under list, you have array list and the array list and the vector list, array list and the vector. Under the queues, you have priority queues, you have the priority queues, and then you have the linked list, like a delay queues. Likewise, you have linked list and the priority queues. And the set interface, you have hash sets. Likewise, we have the sorted sets. Likewise, we have. Then the collections framework we have mainly. You can see here the map also should comes here. Right now we have the map. Map has hash table, hash map, and the navigatable map. Likewise, basically, the collection framework comes with list, set, queue, and map. And also, it has some set of implemented algorithms as well. Right. Now, the collections framework. Now, when it comes to collection framework, you can say about the list framework, the list collection, the set, list, and the queues and the maps. Right. Now, there are a few basic operations available in collections framework. You can add object to the collection. You can remove objects from the collection, and you can search specific object from the collection. You can retrieve it, and you can loop through the collection. Likewise, these are the basic operations available in these collections. Therefore, main core concrete implementation classes, as I said, we have map, set, list, queues, and some set of defined collections interfaces and arrays we have. And then here under this, we're going to talk about lists. Under this array list, we're going to talk about the array list. Right, then list means list of things, set means unique things, maps means things with unique ID, and queues means things arranged by the order which they are to be processed. Right, now here we have already been familiar with the arrays, so I'm going to talk about the list. When it comes to the list interface, the list interface has uh, we have the list and the array list and the vector, array list and the vector, array list, vector, and then we have the linked list as well. Then there are three list implementations. Then array list, vector, linked list. Therefore, the list compared to list and the null list is right now the list has that null list doesn't have a set of methods related to the index. Then again, when it comes to array versus a list, if you say array and array list, okay, I'll give you 1 minute just to find out and tell me what is the main difference between array versus an array list. What are the main differences between array versus array list? Array versus array list. Yes, correct. Yes, the array list and the array, the main difference is arrays, you have to declare the size. And the array list, you don't have to declare the size. Array list grows dynamically. When you're adding the values, it keep on growing. But the array is not like that, right? You have to define the size, and then there's a problem with the indexes. If you have to make sure you are within the limit of the given index size. Therefore, right now, before this collections framework, right now, you know, this collections framework came into play after Java 1.2, I guess. Oh, yeah. Therefore, this framework, which means a set of classes and interfaces in order to make a concrete architecture to implement new features. Therefore, uh, we had this collections framework. Then before the collections framework, there were standard methods for grouping Java objects. Then arrays and the vectors were the only things we had before Java JDK 1.2. And then arrays and vectors, we have grouped the objects. Therefore, all of these collections had no common interface, though the main object is the right now to implement these independently, and there is no relationship. And then where there are very less methods, and the efficiency for inserts and removing elements and finding elements were very slow. That's why the collections framework has been introduced. Then from the collections framework has powerful inserts and powerful sorting, powerful searching methods, interfaces has been implemented. Right. Therefore, using this collections framework, we have the mainly a list, set, map, and the queue and the list. This cares about the index. And then when it comes to other types, that means map, set, and the queues. Right now, there are no methods related to the index. Then according under the list interface, we have to talk about array list, vector, linked list, and then we'll see how to declare an array list, and we'll see how to work with the array list. And before that, set cares about the uniqueness. Therefore, in a set collection, you can't have duplicates. Then set doesn't allow duplicates. Then three set implementations are hash set, linked hash set, and the tree set. Under the map interface, maps cares about the unique identifiers. Then map has a unique key to a specific value where the key and the values are objects. Then the map implementations are hash map, hash table, linked hash map, and the tree map. And the queue interface, there are different the mechanisms the queues working: first in, first out, last in, first out, or the priority queues. Likewise, like F4, F5, F4, likewise, there are different queue operations, the queue mechanisms we have. Under that, one main implementation is priority queues. Even in the computers, when it comes to shared jobs, it works with the priority queues, right? And then let's see how to work with the array list. Array list over arrays advantages are it can grow dynamically and it has powerful insertion and search mechanism than the arrays. Right now, let's see how to declare an array and so right now, we have 46. Right now, let's declare an array and see how we can declare an array list. Okay, array list, not an array. Right now, here I'm going to declare an array list in my class. Right now, we need to declare array list. Right now, and right. Then also we have, I forgot to talk about the advantages of the Java collections framework because of the collections framework has consistent API because it has the basic set of interfaces for all set, list, map, and the queues. Then therefore they have common set of methods as well. So it reduces the programmer's effort because programmer doesn't have to worry about the design of the collection because he can just focus on the whatever the logics. And then it has powerful or the efficient algorithms interfaces declared for in order to increase the program speed and the quality. Right now, now we'll see the certain common objects we have, common methods. You have add method, uh, clear method, contains method, and equals method, hash code, max, remove, remove all, likewise split, size. Likewise, we have certain set of methods, common methods available for all the collections. Right now, we're going to talk about the list interface. Under the list interface, we're going to talk about the array list. Right. Now, you know that list is a child interface of the collection interface. And this interface is dedicated to the data types which we can store in a sequence manner with an index value. Right, with an index value, we can store the values in sequence. Therefore, the array list, vector, stack, and there are various classes implement the list. Then, if you want to create a list now, you can use list. All right, list. And you can have the generic as well. Right now, we can have a list and then list L1 equals new array list. Right. Right now, list L1 equals new array list. Likewise, we can have right now when you're declaring the list, you can have the type of objects you gonna have. Like now, if you want to store, let's say, string type of objects, then you can say string type you can declare. So you need to have new array list. Right now, if you are right now here, also we can declare this when you're declaring an array list, the type of this array list objects as well. So uh, we can create an array list like this. Right now, first, either by creating a list type reference. Then you can have L1 dot add, let's say, hello. Let's say we have string s equals hi. And then if you want, you can have the list dot add string object as well. Right now, let's print the list one dot size. You can print the size, and then you can go through four string objects available. String s in L1. You can right now. What does it say now? Okay, not in. No? Right, I got right. Okay, so right now, we can just work like this. Now we can create an array list using this manner as well. So now this is what the one way that it uses list interface. Array list uses list interface. So array list. What is an array list? Array list provides a dynamic arrays because which can grow dynamically. Therefore, this may be slower than the standard arrays, but this will be helpful in programs where when you have to do a lot of manipulations in the arrays if required. The size of the array list is automatically increasing or automatically decreasing automatically, so it grows dynamically. Therefore, array list allow us to randomly access the list. And right now, can you use the array list for the primitive data types? Right now, string is a reference, right? Right now, let's say whether I can work with the primitive data type. Now you can see I can't. Then it says required reference found in. Therefore, remember array list won't work with the primitive data types. So if you try to declare an array list, you can declare array list like this method as well. Array list and the type of values. Let's say if I say int, which is the primitive data type, numbers and equals new array list. Right. Right now, when you try to do so, you can see you will get an error. Found reference found, required reference found it. So you cannot use the array list with the primitive data type. So you need to, if you want to have integers, you need to use the wrapper class integers. So you can store the integer objects, not the primitive objects, now using the wrapper class. Right now, you can have the numbers dot add 10. Oh, you can have numbers dot add new integer 25. Right, likewise you can add the values and we can display the numbers dot size and we can iterate through for integer I in numbers. You can display the I. Right now, you can see here Now, you can't have remember, you can't have the primitive data types when you are using, you can't use the primitive data types when you are declaring the array list. If you want to use the primitive data types, so you have to use the wrapper classes of those. So basically, you need a reference. Now, I have been talking about the array list. So let's create uh, right. If you want to remove also, let's say number dot add number dot size, and then if you want to remove numbers dot remove, and then if you want, you can pass a specific object or you can pass the index. Likewise, if you want to remove all, you can do it. Likewise, these are the certain methods available. Not only these methods, you can see add and add into the specific index, add all, clear, clone. Likewise, there are several supporting methods are available in this collections framework. That's one advantage of having more common methods for uh, these objects. Right. Now, let's see how to create an array list of our own. And for the item type, now you can have it for the reference type. No? Then array list, I can say item type objects, array list, item type objects saying items. And then you can have new items, new array list right now. So the array list items can have only the item type objects. Then let's say items dot and we need to pass the item objects. Right now I need to pass the item ID and the item name 101 test quantity 10 price 199.99 F. Right. Right now, let's me have some set of values. 103, 105, 102, 104. Right. Chair, desk, bed, table, stools. You can have armchair, quantity 9, quantity 5, yeah, quantity 2, 100, 20. Price is 999. Desk, you're gonna say 699. Bed 1999. Table 1599. Armchair 1199. Right now, likewise, you can have some set of values added. And so now you can, if you want to print out this, you can have for you can do it in either way, right? When you are using the for loop, you can say I equals 0, I less than, we don't know the size, so items dot size. And then we can print what? Items dot get by passing the index. Right now, likewise, we could print. Right now, or else using the enhanced for loop also, if you want to do this, that is also possible. We know that for each loop, right? For item type objects, item I available in items list. So print, okay, we have, because of the brackets are not missing, not available, so that's why it doesn't give me, right? Okay, then yeah, right now I'm printing the values in a separated by space. So here you can see initially here it would print using the normal for loop, and then here it prints using the enhanced for loop. Right now these are integer. Now this is a reference now. Right now I want you to quickly create. Now my battery is running out quickly. Another 37% remaining. So quickly create array list with integers. Shall I show you? Then rather, right, okay, I'm gonna create array list with integer type. So new array list. Now I need to add some set of values now. Okay, right now we'll leave this for a while because I will come into this in a little while. Right. Right now I'm gonna create an array list. I'm going to create an array list in order to store integer type of objects. So I'm going to use the wrapper class integer nums equals new array list. Right. So now in order to add the values into this numbers dot add, I'm going to add some set of values. 10, 20, 15, 15 and 5. Let's say 5. And then I'm going to print these values for integer I available in nums. Okay, I'm gonna print the I values right now. This is how I'm gonna print this now. Now this would print according to the order I have. Now since this is an wrapper class of integer type, so if I want to sort this, now you can see it gets sorted 10, 20, 15, 5. Right now, if I want to sort, then we can have numbers dot. Do you have right now? We have sort. Now we have to have the we need to pass the comparator interface, right? If not, we can use collections dot sort. Then we can pass the number list. Now this is integer types. Right now this will get sorted in ascending order. Now you can see this will get sorted in ascending order. But right now for this array list items here we can't sort like this because now this array list items in the type of items class. So if I try to sort in according to the default implementation of the sort methods, right now I cannot do it. Now you will see I am getting an error saying no suitable method found for sort because we have defined a custom type. So let me quickly go through right now some interfaces which we can use to do that. Right. Now, we have a set of methods right now, a set of interfaces which we can implement. You can search on that called comparable interface and the comparator interface. Comparable interface and the comparator interface. Right now, comparable interface, I'll show you how we can use the comparable interface. Now, remember, if you are implementing the comparable interface, right now, I don't need the numbers at this point. Right now, if we are implementing the comparable interface, then that has to be implemented in the item class, right? Right now, go to the item class and then declare it as you're going to implement the comparable interface. Comparable interface, the type of objects you are referring is item type objects. implement the comparable interface, right? In the class declaration type implements comparable interface. Since if you are implementing the comparable interface, you must override the compare to method. You must override the compare to method. Then it says, once you type this line, it will give you an error saying, does not override the compare to method. And it is an abstract method. Now, you know, when you heard the abstract term, abstract means you are not at the place it has declared, it is not defined, that not implemented the method body, and the subclasses has to implement. So if either you can make this class as abstract class if you don't want to implement it, otherwise now we have to implement it. So now we need to implement the compare to method. Right. Now I'm going to implement the compare to method. Right now, if you want, you can right click and then select insert code. And then you can select implement method. Then you will see comparable interface compare to. Or else you can just type public int compare to. Right now, this is an integer return type. So I can return only 3 types of values now. The positive, negative, 0. Then here what it does is, I want to, let's say, compare. Now we need to write our own mechanism. Right now, my mechanism is to, my logic is to compare with, now if the item ID, compare by the item ID, let's say here, the item ID. If the item ID, if the ID is greater than the object.item ID, I will return +1, positive. If ID is less than the object.item ID, I want to return a negative value. If ID is equals to the compared object ID value, I need to return 0. I can write if conditions if you want. Or else I need to return a positive value or negative value 0. So if you want to sort in ascending order, this is what you have to do. The same thing you could write it as, you have to return an integer value. So return ID, item ID. This we are talking about the item ID, no, item ID minus object dot item ID. If the item ID is greater than the compared object item ID, it will return a positive value. If the current item ID is less than the object item ID, it will return a negative value. If both are the same, it will return 0. Therefore, same like rather writing the three if else if and else statement with 6 statements altogether, I can replace it by just one line. Right. Now I have implemented this, the compare to method. Now I can compare now. Now I can compare the objects. Now I can collections.sort items. Now this will get sorted according to the way I have declared the compare to method. That means according to the item ID ascending order. Now there is no such order for item type objects in item type objects, in items class, item type objects in items. Right, I'm printing this right now. First, I'm gonna print, and then I'm gonna have a space, and then I'm gonna sort it, and I'm gonna print it. Right now, this implementation should sort in ascending order. Right. Now this would be sorted in item ID ascending order, but unfortunately, we are not displaying the item ID. So quickly, let's change the item class to display the item ID. All right. Then we have item ID. I'll display at the beginning item ID, and I need to have some space beforehand. Item ID. Right now, I have changed it to display the item ID as well. Now, this would display the item ID. Right now, first it would print item IDs without items with no any order according to the inserted order. Now you can see it gets sorted according to the ascending order. Right. If you want to do it in the descending order, it's very simple. You need to just change the positions. But here, we need to compare by object.item ID, object.item ID minus item ID. Right now, object.item ID minus item ID. Right now, this would sort in descending order. Now this would sort in descending order, right? Now you can see this would sort in descending order. Not only the item ID, if you want to sort by the price, that is also very easy. If you want to compare by the price, then the problem is now price is a float value. So if you want to sort by the float values, then if you are doing it, then you need to cast it into the integer value, right? Now this you can do only for one way. No? Let's say now you need to sort in different ways, right? But now once you implement the comparable interface, now this becomes the natural sorting order of this item class. Once you implement the comparable interface, now what is this comparable? You should read. Comparable is the imposes total ordering on the objects of each class that implements. This ordering referred to the class natural ordering, and the class compare to method is referred to its natural comparison method. So now we have, once you implement the comparable interface, it has become the natural way of ordering the items, Now that's a comparable interface. So now let's say I want to sort by the price or sort by the quantity. So I need to come up with a new class. I'm going to write another Java class called sort by quantity. Sort by quantity. I'm going to come up with another class called sort by quantity. Right now, the sort by quantity is a separate class. Now, I want to say sort by quantity implements the what? Sort by quantity implements the, not the comparable interface. Now, this time comparator interface, comparator. Now, item type objects, I'm going to compare. Right now, when you implement the sort by quantity also, you get the error. This is not an abstract class, so you have to override it. Yes, you have to override. Now, what method you have to override? Once you move your mouse over this error, it shows the compare method is not available. So you need to override the compare method. Insert code, implement method, compare. Right, now let's write how to, the way you want to sort this two objects. Now, this is comparator interface implemented in a separate class outside the item class. So we have to pass the both objects to be here. Now we need to compare. Now, most probably by the time, right now, when you are declaring a class, now most probably these would be private, no? Because like most probably when you are declaring a class, right? What you do, you use the encapsulation, no? You generate the getters and setters, whatever you want, and you make it encapsulate. So all these fields private. So now by this outside the class, you cannot access these using the dot operator. So you have to go through the public methods declared. So now you need to say, let's say I want to sort by the quantity, by availability in descending order. Then I'm going to say return O1. Now, if it is ascending order, O1 dot get quantity minus O2 dot get quantity. O2 dot get quantity. Get quantity. Right now, this is for the ascending order. Right now, this is for the ascending order. Right. If you don't want to do this, if you want to sort in descending order, then you have to just switch O2 dot get quantity minus O1 dot get quantity. Right. Now let's print this as well. Right now, what you want to do here, I want to sort the items by sorted by item ID, sorted by item ID. Right now, again, I want to sort by now. I want to sort the items by quantity. Quantity descending order. Right. So now I need to say collections.sort items, and then you need to pass the class name, which is a new sort by quantity class. Right now you need to pass the collection name with the class name. So it will get sorted according to the given class. Right now, this will be sorted by the quantity in descending order. Right now, you can sort it by quantity and descending order is 129.52. Right now, this is how it works. Right, so what are missing here? Let's say I want to sort it by the price, sort by the price as well. So I'm going to go up with another class for you to do it from the beginning. Create another class. I'm going to name it as sort by price. Now sort by price. I need to implement what is the interface? Comparator interface. Comparator. The type of objects we are talking about, item. And then you have to override the compare method. Now you know this would return integer value, and the name is compare, and then we have x and integer y. Right now, what does it say now here? Sort by price is not abstract, does not compare item. Okay, not integer. Here this has to be item object. No, sorry. Item x and item y. Right now, we have implemented the compare method here. So we need to return uh, sort by the price. Let's say price ascending order. Then x dot get price would be a float value. Now get price is returning a float value minus y dot get price. Y dot here. Y dot get price is also a float value. Right now, these two are float values, so I'm put that inside the brackets, and then I'm going to cast it into a integer, and then I'm going to return an integer value. Right now, first here, this would inside this bracket, I have a float value, so I'm casting into an integer because if I don't mind about the value, I'm just checking about the zero, negative, and positive value. So I'm gonna do it by ascending order. Now price in ascending order. So let's say sorted by price. Sorted by price ascending order. Right now we need to pass the method which is sort by price. Now if you run this, it would get sorted according to the price. Now this would get sorted according to the price. Right now you can see 600, 900, 1100, 1500, 1900. Likewise, it gets sorted. Right now, sorted by price. Right now, this is how you can create the custom classes, and this is how you do the sorting. Now, what we did was we have used comparable interface to implement in the item class itself. So this become the natural sorting method of this item class. Therefore, if you are implementing comparable interface, it is a must to implement the compare to method. So we have implemented the compare to method. This is the natural sorting comparison for the item class. So since that is a natural sorting method, you don't have to pass a class here. You just need to say collections.sort, and you just need to mention the collection name. But thereafter, we want to have some other ways of sorting the items. So we have implemented sort by price. So we wrote a different class sort by price, implements comparator interface. Now, comparator interface also, you can just read what this comparator does. This is a comparison function. This imposes the total ordering on some collection of objects. Comparators can be passed to a sort method to allow precise control over the sort order. Now we have used the comparator. Therefore, if you are using comparator interface, it is a must to implement the compare method. Right? Even though you don't want to write it, you can just right click insert code, implement. Right now, how you can do it? Let me show you. Right now, if you want to have the insert code, right click insert code, select implement method, select the compare to method, and click generate, and then change the body of this, and then that is how you implement the this should be O1 and this should be O2. right now, because these are the two para checks you have passed, right? And this is how you generate the compare to method, right? Compare method with for the comparator interface, right? Now this is how you do comparator and the comparable interfaces, right? Now we have battery 23%. Okay, I'll give you 1 more minute for you to quickly try out. Then we can start with one scenario with menu-driven application where I can show you quickly. Then you can start working on it. Right now, quickly try out. I'll give you 1 more minute. Quickly work out. Right. Okay. Right. Let me remove all these classes and let me come up with a new Java class called class car. Right now, class car has some attributes like integer year, right, and string model, string model, and integer quantity, and the float price. Right now we have only these attributes, right? So I need to generate the constructor. I'm gonna generate the constructor here, and I'm gonna generate the getters and setters for me. I'm gonna generate the getters and setters, and I'm gonna encapsulate this. And also, I want to have the toString method declared here. Therefore, I'm gonna have the toString method. When I have the toString method, I'm gonna display. Right now, not the year first. I'm gonna display the model. I'm gonna display the model, and then year model hyphen year, and then I'm gonna have the quantity available and the price. Right now, this is how I'm gonna display the paths. Right now, I'm gonna do it like this, and then if you want, you can implement the two equals method as well. Right click, insert code equals, only the equals to check by the car ID is not there, no? Okay, how can we check the car? Here? Okay, I'm not gonna do it. When you're doing, you can have a car ID at the beginning and then you can do it. All right. So, right now, why don't we do it? Then you can continue later on, no? Private string ID. So we'll generate the constructor, including the car ID as well. and we'll print the car ID. I'm not gonna print the car ID here, and let's include the getters and setters as well, only for the car ID. Right. Now we have the toString method, and let's say equals method also I'm gonna have insert code equals. I'm gonna check by the car ID. Hash code not required. No? Right. What I'm gonna do, if this object is an instance of the class car, if object an instance of class car, okay, I'm gonna create object called other, and then I'm gonna check whether if ID, if car ID equals to other dot car ID, I'm gonna return true, else I'm gonna return false. I'm gonna return false. Right, now we can do it like this, and then we are done with the class car. And also I want to have subclasses for the class car, and I'm going to create how long I have the 19. We might able to, right, let's do it quickly. Right, I'm going to create for the class car, I'm going to create car types. You know, not do that as well. Right, now we'll do this in a different time, and then I don't think the battery would be enough for this.